Okay, great. Right. So let us continue with the discussion. And in today's session, what we are going to talk about is some important questions, what you encounter during the telecom and 5G interviews, right? And especially from the perspective of entry-level engineers, when you are relatively new to the telecom world. And in this discussion, I'm not really going to get into the areas of wireless fundamentals, multiple access techniques, and all those things. Of course, those are going to be very important questions. But in this discussion, I'm going to talk about more questions related to telecom networks, 5G networks, and the related topics, right? Of course, before we move to that, as I mentioned, some questions related to wireless fundamentals, like when you talk about frequency, bandwidth, etc., and then talking about multiple access technique, TDMA, FDMA, OFDMA, modulation, the channel interference and other stuff. These are going to be important, but that's not what we are going to discuss during this discussion, right? So let us get started. And I've just listed some of these questions which are typically asked from the perspective of the network architecture. Right. So this is going to be based on the 5G network architecture, talking about various different network functions and what do they do, right? So talking about what is AMF, knowing the full forms of these network functions are very important. At the same time, brief functionality of these network functions are very critical for these discussions. Also, we talk about some kind of call flows where we talk about the UE, getting into the network. We typically refer this as a network entry procedure. But after that, UE talks to the core network in the form of initial registration, and then it does some kind of PDU session establishment. These are some interesting questions what are normally asked in the training, in the interviews. And another area which is 5G new radio is pretty important area, and the different protocol layers and the functionality of those layers are going to be very important questions. I will be talking about some of these things in the upcoming slides. And then open RAN is also a very new term in the telecom world. It is there just from last 4 or 5 years, and it is really picking up well. Of course, it comes with a lot of challenges as well. And what open RAN is, why do we need it? What are the architectures we follow in open RAN? These are the various questions which are asked in interviews. Again, we talk about what is cloud native, and telco cloud. I'm going to talk about that in the upcoming discussion. When we talk about cloud native, another natural question which comes in the interview is, okay, how do we really deploy the 5G network on a cloud native architecture? Both the radio network and the core network can be deployed on a cloud native architecture, and we will talk about from a perspective of core network. During this discussion, they also ask about what is Docker, what is Kubernetes, what is containerization, virtualization, and things related to that. So you should be a little bit aware about all these terminologies. Why do we use it? What are the benefits? What are the benefits or the drawbacks of these things? So we should be aware about these things. Then talking about identities like SUPI, SUKI, GUTI, who allocates what is the purpose of using SUKI? These are some of the other questions which are being asked. And then talking about the architectures like standalone architecture and non-standalone architecture. And then talking about various interfaces and the protocols. Right. So let me go through all these questions one by one. And I think that will help us to understand what are the typical things we need to have in our mind as a picture so that we can talk about it. So very first question, which we talk about as a 5G network architecture, even though, as I mentioned multiple times in during our training program, that there are 28 different network functions which provide 102 services, but not all of them are equally important. Some of them are very critical for the call flows and very network entry, etc. So in this picture, we have some important ones. Right, so here we see the G node B, which is the base station, which will be further broken down into multiple pieces in Open RAN, but it connects to the AMF for the control plane and the UPF for the user plane. In addition to AMF, another two network functions which are important for the initial entry or initial registration is AUSF, which typically takes care of authentication, and the UDM, which typically manages the data, which is in the background stored in the UDR or the Unified Data Repository. The PCF takes care of policy control, where it provides the QoS policies and the charging rules. The SMF takes care of session management function. UPF takes care of the user plane data. DN is nothing but the internet or any other data networks where we are trying to connect. The NRF is typically NF repository function, which is like a yellow pages for or Google for our network function. So it helps all the network functions to find each other by having a entry in the NRF. So every network function which comes up, they have to publish their information in NRF, and then NRF has to provide this information whenever somebody is trying to connect to that particular network function. NEF stands for network exposure function, where it can connect to the third-party vendors or third-party companies to access the capability of the 5G core network. The NSSF is network slice selection function that is typically helping the AMF to choose the right sets of AMF for the user for a particular request. Right? So these are the various network functions which we typically talk about. But there are a few more network functions like UDR, uniform or unified data repository. We also talk about NWDAF, network data analytics function, and there are many more as we have discussed in the earlier discussion. All these network functions, what you see here, they communicate to each other over HTTP2 protocol, and they normally share the information in the JSON formatting. And this is typically the control plane part of the core network. In the user plane part of it, we have just the UPF in the core network, right? Of course, GNodeB does both the control plane and the user plane part. And between user and GNodeB, there is a complex protocol stack, which we will be discussing in the upcoming discussion. So this is one of the very important question you will come across whenever you say, I know 5G. They are typically going to talk about what is AMF, what is SMA, what are their names, what are their functionality, what do they do, right? So having a good idea about all these names and network functionality, their brief functionality is surely going to help you during the interviews, right? When we talk about call flows, there are three different call flows or three different initial procedures which are typically asked in the interviews. The first one is the network entry procedure. In the network entry, this communication is between the UE and the GNodeB, right? So in this case, we typically talk about when the UE communicates with the GNodeB and the core network doesn't come into play. So in this scenario, we talk about the typical scenario of having PSS, SSH, and PBCH, which carries your MIB. And after that, we are also going to listen to another information, which is called a SIB1. After listening to all this information, after listening to all this information, we will get to know about the PRECH reasons, and after that, we will be able to do the random access. So having the random access procedure and understanding of random access procedure is also going to be important, where we normally talk about two procedure. One is called a CFRA, and another one is called a CBRA. CBRA is called as contention-based random access, and CFRA stands for contention-free random access. So in this case, it is going to be competitive procedure. It will be non-competitive procedure, right? So this is something what we need to understand at the network entry level, where we talk about PSS, SSS, PBCS. Sometimes they also ask you what is PSS plus SSS, which is typically also called as PCID, physical cell ID, where PSS has values 0, 1, and 2, and SSS has values from 0 to 335. So put together, they give you values from 0 to 1007. So total 1008 values and range from 0 to 1007. So if they ask you, okay, how many PCID in 5G, it is 0 to 1007. In case of 4G, these PCIDs were 504, which is from 0 to 503, right? So these are some questions which I've seen in the past, people asking those questions. How the network entry procedure is working? What are the different entities, PSS, SSS, PBCH, random access procedures, etc. Right. The initial registration comes into play when UE start talking to the AMF, via GNodeB. So in this case, UE is trying to register with the AMF, but in turn, the AMF talks to the AUSF and UDM and UDR in turn. I have already shared the protocol logs and the detailed discussion around it. So you need to look at step-by-step method, how they are talking about it, how that talking to each other, and every discussion happens via NRF. So even though you're not comfortable looking at the protocol logs, you can just look at the slides or some brief introduction about how the call flow works in the 5G network. In the PDU session procedure, the user is trying to reach to SMF to create a session. However, again, this goes via AMF, and AMF will pass it on to SMF, and SMF will pass it on to the UPF. And in that case, G node B will connect to UPF, UPF will connect you to the external data network. So in this case, your call, the session will go, the user plane part of it will from UE to G node B, G node B to UPF, and from UPF to the data network. So during the PDU session procedure, we are trying to set up this path. To set up this path, we also need to involve AMF and SMF. And in turn, SMF will also talk to UDM for subscription. It will talk to the PCF for policy related data, right? So for mobility management, which is the initial registration, AMF becomes the center point of contact. For session establishment, SMF becomes the main authority. So anything related to mobility management or registration, AMF will be responsible. Anything related to the session, SMF will be responsible. I have already shared the detailed logs and the slides with you, so you can refer to those slides when you want to learn more about all these things. Now, the another important question which comes into these kind of discussion is the 5G NR. So this is written as NGRAN, Next Generation Radio Access Network, which is typically referred as 5G NR as well. Protocol stack where we talk about the control plane as well as the user plane part of it. Now, if you look closely, in both control plane and user plane, these layers are common: PHY layer, MAC layer, RLC layer, PDCP layer. This is between the UE and G node B, and core network has no role to play in these layers. Right. Of course, some content has to come from AMF, but typically how they are organized has none of the business of the core network. On the highest layer, which is the RRC layer, we are talking with the in the control plane, we are talking with the RRC layer. Right, so we need to know the full form and a brief functionality of all these layers: the PHY layer, MAC layer, medium access control, radio link control, packet data convergence protocol, and the radio resource control. So only the name may not be sufficient. We need to know a little more about protocol layers, at least a brief functionality in terms of hybrid ARQ, MAC scheduler, right? Like ciphering, header compression. So for that, there are some pictures available. I've already shared a lot of content related to these things. And the slides that I've shared, you already have seen all these things in those slides as well. Brief functionality is always there, right? File layer is the most complex one, and it comes with a lot of things related to channel coding, the LDPC coding. It talks about OFTMA, resource block, resource element. It talks about the frequency domain, subcarrier spacing, time slots, right? So these are few of the basic terminology which we have discussed during the training program. So we should be aware about what is subcarrier spacing, what is the variable or flexible numerology in case of 5G. In case of 4G, it was fixed to 15 kilohertz and time slot was fixed to 1 millisecond. However, in 5G, it can vary. I can have multiples of 15 kilohertz and divisions of 1 milliseconds when it comes to the time slot. So what are those numbers? What are those numerologies? You should be having some basic idea about all these things when we talk about it. In the user plane, all these protocols remain same except the top layer, which is now replaced by another layer called as SDAP. In control plane, we had this layer as RRC. Here it is SDAP layer, which is typically helping us for the QoS flow management, etc. So basically mapping these QoS flow to radio bearers. That is the functionality of SDAP. All other layers will have more or less the similar functionality for both control plane and user plane. Between G node B and UPF, we have a protocol which is called a GTPU protocol, GPRS tunneling protocol. Now, another interesting question which is normally asked, because Open RAN is the focus area for many companies nowadays, right? So the G node B, what we were talking about earlier as a single unit, is now broken down into multiple pieces, which are called as ORU, ODU, OCU, which is further broken down into CP and UP, control plane and user plane. The near arteric, non arteric, right? And then talking about SMO, service management and orchestration framework. Right. So having a brief idea about all these entities like RU, DU, CU, RIC, RAN, intelligent controller, both near RT-RIC and non-RT-RIC, and what SMO does will be having a good proposition if you are able to prepare for that. In addition to this, you should also know this ORAN architecture is standardized by ORAN Alliance. So ORAN Alliance is a forum where we create all the standards related to open and all these things. Right. Now, a few terms related to cloud, cloud native and telco cloud. So cloud is basically a very generic term where we talk about computing services like storage, processing, networking, etc., which are delivered over internet. So these services are provided by cloud service provider like AWS, Google Cloud, Azure, etc. These are we also talk about three service models, four deployment models, and five characteristics, right? So three deployment models, when we talk about like infrastructure as a service, we talk about platform as a service, and we talk about software as a service. When we talk about deployment model, we talk about public cloud, private cloud, hybrid cloud, and the community cloud. And then we talk about some kind of key characteristics like on demand, pay as you go, scalable, and go global in a minute, can be public, private, and cloud. So these are various scenarios. These are various scenarios we talk about. Some of the example use cases for cloud are like using Google Drive or Dropbox, or using some web hosting like AWS EC2, and then using some applications like Salesforce, Zoom, etc. Right. So these are some of the example use cases of cloud. The cloud native typically talks about the architectures where we broke, break down our software into microservice architecture. We are trying to containerize these application and, deploying it in Docker containers, doing the orchestration using Kubernetes, etc., and talking about DevOps, CI/CD, etc. So this is more suitable for implementation which are more native to the cloud or more suitable to the cloud. These are some basic architectures and things related to that. And these can be any applications built using Docker, Kubernetes, etc., which can scale across multiple cloud platforms. These are some of the use cases. And then another thing, what typically they ask is the telco cloud. In the telco cloud, we talk about telecommunication network, which focuses on running telecom workloads like mobile core network, both, as I mentioned, both core network and radio access network. And even the OSS BSS system can be built using the cloud principles, which can be based on virtualization or containerization. And here we will talk about the things like NFV, network function virtualization, software-defined networking, etc., where all our network functions like EPS, IMS, radio network, 5G core network, all these things can be built and deployed on a cloud infrastructure. For example, some example use cases, our 5G core network can be built on a telco cloud platform, or our Open RAN or vRAN can be deployed using a telco cloud. So the radio network, the core network, the OSS BSS applications, all of these things can be built on a cloud infrastructure. And because we are doing telecom specific deployments, we normally refer this cloud infrastructure as a telco cloud infrastructure. Now, just to take an example, in this picture, we are talking about 5G core deployment of 5G core deployment on a cloud native architecture. This picture comes from the Samsung white paper. And in this picture, what we see here is we have various containers. These containers are hosting some kind of microservices, and a collection of these microservices becomes your AMF or your SMF. So basically, the AMF and SMF are not created as a standalone monolithic network functions. They are built or created as a collection of containers or a collection of a suite of services, we normally refer it. And these network function now called as CNF, which is called as cloud native network function. Now, another important question when we talk about these things is the terminologies in 5G and 4G, a quick comparison. For example, we talk about the user identities like IME, IMS, ISG, and IMSI number are now called as PEI, GPSI, and SUPI. The SUCI, SUCI is the concealed version of SUPI value, And that is what that is what differentiates 5G from the 4G. In 4G, we always send the IMSI as a plain text whenever we have to send the IMSI. In case of 5G, SUPI is not sent in the plain text. It's sent in the concealed format called as SUKI. All these things like MME similar to AMF, HEW, PGW control plane similar to SMF. The bearers are now called as QS flow, PDN connection, PDU session. PDN is called as data network. APN, access point name, is now called as DNN. Another important thing what we need to note here is, even though they are very similar, they are not exactly same. There are significant difference in many of these things. The other thing which talks about the coexistence of 4G and 5G network, and we talk about architectures like standalone and non-standalone architecture. So we have taken two options for the core network, 4G core and 5G core. And for radio, there are four options: pure 4G, pure 5G, and a combination of 4G and 5G. In this scenario, there can be 8 different options which can be created, but option 6 and option 8, which are disregarded. Option 1 is pure 4G, option 2 is pure 5G. Option 3 was one of the initial deployment of the 5G network, which is referred here, where you're connecting LT as a master, NR as a secondary, and you are connecting it to the core network or EPC. It is referred as a NSA architecture, non-standalone architecture. However, there are other options for non-standalone architecture, but option 3 was considered as one of the very first architecture deployed for the non-standalone. When you're deploying it 5G core network and NR with only option 2, we normally refer this as a SA architecture, SA standalone architecture. In this case, the radio network of 4G, 5G is connected to the core network of 5G network, and it is standing alone, and that's why we call it a standalone architecture. However, this discussion can get even more complicated with or more options available, but generally and at a high level, when we speak, we consider option 2 as a standalone architecture and option 3 as a initial NSA architecture. So if somebody is asking about SA and NSA, SA versus NSA, so SA is option 2, NSA is option 3. However, there are more complexities in option 3 also. They have option 3A, 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 3X, right? So I'll not get into those complexity at this stage, but if you're interested to know more about it, you can also refer to these things. What is 3A, 3X, etc. Right. So these are a few of the things what we need to keep in mind. Even though you think that I'm going little fast here, so don't worry, I'm already recording this session. I will upload this on YouTube and share the link with you, so you can go through these things at a later stage whenever you get time. And also you can stop and look for some references and try to learn those things. Right. Another interesting question which is being asked during this discussion is like the interfaces and the protocols. We talk about N1. It's not NI, it's N1. N1 is UE to AMF, interface between UE to AMF, which is typically communicating using a protocol called as NAS. The N2, which is G node B to AMF, carrying NGAP protocol messages. G node B to UPF, GTP-U protocol. So this is not GTP, GTP-U protocol. And the SMF to UPF, for control plane, we have PFCP protocol. And for user plane, we also use GTP-U protocol. Between all the core network control plane like AMF, SMF, UDM, UDR, we typically do a service-based architecture where all these devices are communicating in the HTTP2 and the JSON kind of communication. So if you can look at the overall architecture, how these network functions are communicating, what are the different services provided by these network functions, that is going to help you in the discussions. Right. So that was a quick session to talk about all these important topics. Right. If you have any further questions, you would like to know more about any of these things, we can talk about it. If not, we can close the session, and then maybe I can provide you any reference material, any details you need. So that's all from my side. Mohit, any follow-up questions from anyone before we close?